Welcome to a new video. In this video, we shall look at what the basic things you have to know in chemistry. What you have to know in chemistry, things that will help you to understand chemistry better, to be an expert in chemistry. I want to open a new door to you. I want to open a new door to you, the door of chemistry, the beginning of chemistry. From here, you can be an expert in chemistry. What are the things you have to know in chemistry? The first thing, you have to know the meaning of chemistry. What chemistry deals with. What is chemistry? Chemistry is just the study of composition, properties, and uses of matter. Chemistry is just the composition. Chemistry is the composition, properties, and uses of matter. Uses of matter. Which I can simply say chemistry is the study of CPU. CPU is the study of CPU. Composition, properties, and uses of matter. CPU. That is the meaning of chemistry. Chemistry is the study of composition, properties, and what? Uses of matter. Then what are those things you have to know in chemistry? What is chemistry made of? Chemistry, what we study in the chemistry, in the subject called chemistry science, is just what? Matter. And what do we study under matter? Composition of matter, properties of matter, and the uses of matters. Those are the things we have to study under chemistry. Then for you to study composition, property, and uses of matter, that means we have to look at matter in different forms. We have to look at matter in different forms. We have to look at matter in different forms. Before we look at matter in different forms, what is the meaning of matter? What is the meaning of matter? Take note. Matter is anything that has mass and occupies space. Take note of that. Is anything. It could be anything that has what? Mass. It must have what? Mass. And it must what? Occupy what? Occupies space. That means matter is anything that has mass and what? Occupies space. That is matter. And what is mass itself? What is mass? You have to know the meaning of mass. Mass is the amount of matter in a substance. The amount of matter in me is my mass. Don't forget, I told you, matter is anything that has mass and occupies space. I'm a matter because I have mass and I'm occupying a space. The mass is the amount of that matter in a substance. The amount of matter in me is my word, mass. Please take note of that. But when it comes to physics, there's difference between mass and weight. And take note, mass is constant. Everywhere, mass is constant. But in physics, there's difference between mass and what? Weight. Take note. Weight is gravitational pull on an object. Mass is the amount of matter in an object. That one is in physics. There are two different things. Take note of that. Then, under this matter, for you to know the composition, properties, and uses of matter, that means the way you can know them, that means this matter can be studied in form of state of matter. You have to know the state of matter. You have to know what? State of matter. Take note of this. You have to know what? State of matter. In our daily life, everyday life, three states of matter are observable. In everyday's life, three states of matter are observable. But two states of matter, other two states of matter, can occur at a very extreme condition. Take note of that. In our everyday life, we have three states of matter which we observe. They are observable. We have three states of matter which are observable in everyday's life. Then another two can occur at an extreme condition. Take note of that. That means in that case, I can say that we have five states of matter. Three of them are what? Observable. You can see them in everyday's life. You can see them, they are observable. While the other two occur at what? Extreme what? Condition. Then what are the state of matter I'm talking about? The three that will occur that you can see in everyday's life, that you can observe wherever you are going, you see them. They are what? We have solid. We have liquid. We have what? Gas. These three, they are observable in our everyday life. Then these two, they occur at extreme what? Condition. We have plasma. And we have both esteem condensate. Both esteem condensate, which I can call BEC. BEC. This both esteem condensate can occur at extreme what? Cold condition. It occurs at very cold condition. Very cold. It has what? The lowest temperature among the five states of matter. At a very cold condition, you can have what? BEC. Very cold condition. Very cold condition. Take note of it. Example of this plasma, we have stars. That means the sun, the comet. They are example of what? Plasma. We have fire. Fire is an example of what? Plasma. Take note of that. These two, they occur at an extreme world condition. They occur at an extreme world condition. And we are familiar with these three. We know example of solid. We see what? Your table, your bag, your books. They are example of solid. Example of liquid, we have what? Water, your blood. They are example of liquid. Gas, we have oxygen gas, we have nitrogen gas. Those are example of what? Gas. Take note. We have state of matter. We can study this matter in form of state of matter, which are what? 5. 3 of them, they occur. You see them in our we see them in our everyday life. They are observable. Then we can have state of matter. Can be studied in form of what? Changes of matter. Changes of matter. And under the changes of matter, we have 2 changes of matter, which are very important. We have physical change. Take note, physical change. And we have chemical change. We have physical change, we have what? Chemical change. Then, this matter can be studied in form of classes of matter. Take note of this. Classes of matter. These classes of matter can be divided into 2. We have pure matter and impure matter. Take note. Classes of matter can be divided into 2. We have pure matter. And what? Impure what? Matter. We have pure matter and what? Impure matter. Pure matter, we have 2 of them, which are elements and what? Compound. Element and what? Compounds. Then impure matter, we have what? Just mixture. Mixture is an example of impure matter. If they ask you, is there your Jamb question? You can have it in your Waec question. Even Jupeb question, you can have it there. Which of the following is an example or is the purest form of matter? The purest form of matter is what? Elements. Elements are the purest form of matter. That means elements is the purest form of matter. Element is the purest form of matter. We have pure matter, we have element and we have compound. But the purest is what? Element. Take note of that. And you can have this. They will say, which of the following is a pure matter? You can have option A, sand. Option B, seawater. Option C, air. Option D, urine. Urine. Which of the following is a pure matter? That is, which of the following you will look for the one that is what? Either an element or a compound. I told you, pure form of matter are what? Element and compound. They are pure matter. Then look at the option. Which one of them is what? An element or a compound? That means the question is identify the word pure matter. Take note of this. This one is not the answer. It's a mixture. Urine is a combination of what? Water and what? Salt. And there are so many other what? Constituents in urine. Take note of that. Urine contains water, it contains salt, and so other what? Constituents. Air is a mixture. A mixture is also what? An example for an impure. Mixture is what? An impure. Air contains what? Oxygen gas, nitrogen gas, carbon dioxide, and some what? Noble gases. It's a mixture. Can never be the answer. Seawater is also what? Salt solution. Seawater contains water and what? Salt. It's a mixture. Can never be the answer. Sand is an example of a compound. Sand is an example of a compound, which is what? Silicon oxide. Sand is a compound. Take note. Sand is a compound. Soil is a mixture. Soil is a mixture. When we get there, we explain more of this. Soil is a mixture. Take note of that. Take note. That means for you to know chemistry, these are the things you have to know. The state of matter, changes of matter, classes of matter, which are what? Pure matter and impure matter. Then under the classes of matter, we are going to look at one particular nature of matter, where you have what? Atoms, molecules, and ion. When we get there, please take note of that. Let us take this one, state of matter. Let us look at interconversion of state of matter. Interconversion of state of matter. Interconversion of state of. Let us look at interconversion of state of matter. Interconversion of state of matter. Interconversion. Conversion of state of matter. Interconversion of state of matter. What is interconversion of state of matter? This is a process in which a state of matter can change from one phase toward another. When you have state of matter changing from one phase, changing from one phase to another phase, to another phase. When you have a state of when you have matter in a particular state, changing from one phase toward another. For example, when solid is changing toward gas, when gas is changing toward solid, when liquid is changing toward gas. That means it's a process in which you have what a matter changing from one phase to another phase. That is interconversion of state of matter. Then let us look at the interconversion of this state of matter. When you have this, you have solid, you have liquid, you have gas. Let me assume you have plasma here. Plasma. Then this can change to this. Look at my arrow. Solid changing to what? Liquid. Look at the arrow. Solid moving, changing to what? Liquid. Liquid can change back to what? Solid. Look at that. Look at this. You can have solid can change to what? Can change to gas. And gas can change back to solid. You can have this. Liquid can change to what? Gas. Gas can change to what? Liquid. Then you can have gas changing to what? Plasma. Plasma changing back to what? Gas. Let us look at this. Let me give this one A, B, C, D, E, F, G, H. Let us look at those. Let us look at those things. Let us look. The process in which this solid, liquid rather, is changing towards solid, that is A. Look at it. Liquid changing towards solid, A. Liquid changing to solid, that is A. Liquid is changing towards solid. For example, when you bring your ice block, take it out of your deep freezer, put it down. What happened to the ice block? It will change toward, liquid towards solid rather. Liquid to solid. When you have your water in liquid state, you put it inside your deep freezer. What happened to the liquid? It will change towards solid. The liquid will change towards solid. The process by which the liquid is changing to solid is A. And that process is known as what? Freezing. That process is known as freezing. I don't want to complicate the issue. For liquid to change towards solid, what happened? What happened in that process? That means cooling is what? Occurring. In that process, what happened? Cooling is what? Occurring. Heat is being what? Taken out. Heat is being what? Taken out in that process. When you have liquid towards solid, your water, you put it inside your deep freezer. Then after some time, you now see it changing toward solid, to ice block. That process is what? Freezing. B. When you are solid toward liquid, for example, you bring your what? Your ice block out of your deep freezer. You put it down. What happened? It will absorb heat from the environment. I don't want to go to the name of the process, endothermic, exothermic. I don't want to scatter your head with that because I just want to give you basic. But when we get there, when you bring solid out of your deep freezer, you put it down. What happened to that solid? It absorbs heat. And when heat is absorbed by a system, that process is what? Endothermic. But I don't want to go into that. Just to give you basic first. Basic. Solid changing to what? Liquid. That process is called what? Melting. Then look at C. Liquid to gas. Liquid changing to what? Gas. That is C. Liquid to gas is called what? Boiling or evaporation. Boiling or evaporation. Some people say vaporization. Boiling or evaporation. The process by which what? Liquid is changing into what? Gas. It's changing to what? Vapor. Take note. Boil or evaporation. Then look at this. Gas changing back to liquid. That is D. That process is called what? Condensation. Please take note of that. This question came out in Jamb 1987. 1987 is J in Jamb 1987. Please take note of that. It's here. You see it in Jamb. You see it in Waec. You see it in Jupeb. Please take note of that. Then look at this. Solid toward gas. That is E. This one is there in your Jupeb past question. Solid to gas. That is E. And that process is called what? Sublimation. And in Waec, is there in Jupeb also? Is there in Jamb? They can ask you which of the following substances can sublime. That means the substance that can change from what? Solid to gas without passing through the what? Liquid state. The substance that can change from solid to what? Gas without passing through the what? Liquid state. Substance that change direct from solid to gas. It won't change to liquid. from solid to gas directly. What are the examples of those substances that can change from solid to gas directly? What are the examples? What are the examples? That process is for sublimation. Then they can have examples. Give examples of what? Substances that can sublime. Examples are, let me write examples here. Example, let me write it under. Examples of substances that can sublime. We have iodine crystal. Iodine crystal. Iodine crystal. We have ammonium chloride crystal. Ammonium chloride crystal. Ammonium chloride crystal. We have dry ice. Dry ice. That means CO2 in solid state. Dry ice. Dry ice. We have camphor. We have naphthalene. They can sublime, but take note of this. Let's go to the next one. From gas to what? Solid. From gas to solid. When substance change directly from gas to solid, that is what? Air. That is air. Then what was the name of the process? Deposition. 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 Example of substance that can do that, e.g., FOROST, frost. Substance that can do that is that when you are changing from gas to solid, air, it's called deposition. Then G is what? Gas to plasma. When substance change from gas to plasma, that process is called what? Ionization. 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 Then from plasma to gas, that is H. That is what? Recombination. 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 Please take note of this. Please take note of this. Please take note of this. Let us look at properties of state of matter. We are only going to look at the three that we are used to, which are solid, liquid, and gas. Properties of state of matter. Let's take the first one, solid. Solid. Properties of solid. The first one, it has, solid has, then right, solid has a fixed shape and a fixed volume. Take note of that. Solid has a fixed shape and a fixed volume. If you look at your book, book is an example of solid. It has a fixed shape and it has what? Fixed volume. Take note of that. Next one, number 2, another property of solid. Solid cannot be compressed. Solid cannot be what? Compressed. Another property of solid. Another property of solid. The intermolecular force of attraction in solid is very strong. It has a strong intermolecular force of attraction. The intermolecular force of attraction of solid is very strong. That means it has strong intermolecular force of attraction between each molecules. A strong intermolecular force of attraction between each molecules. Next one. Solid has high density. Solid has high density. Solid has high density. Solid has high density. Next one. The space between the particles of solid is negligible. Negligible. That means the molecules of solid or the particles of solid are what? Compactly what? Close together. The space between them, the particles of solid or molecules of solid is what? Is negligible. That means they are compactly what? Close together. Let me give you these 5 properties of what? Solid. Let us go to properties of liquid. Properties of liquid. Properties of liquid. The first one, don't forget, look at solid. Solid has a fixed shape and what? A fixed volume. But in the case of liquid, liquid has a fixed volume, but no definite shape. That is liquid. It has a fixed word, volume, but no word, fixed word, shape. Liquid has fixed word, volume, but it does not. It doesn't have a fixed word, shape. That is why liquid take the shape of the container it can be found. If we pour, for example, look at this. Water is an example of liquid. Can you see the water in this word container take the shape of this container? If I pour the water in another word container, maybe a flat word container, it will take that word shape. That is to say that liquid has no definite word shape. It has no fixed shape. It has no fixed shape. It only has what? Fixed word volume. Take note of that. Another one. Liquid can slightly be compressed. Liquid can slightly be what? Compressed. Another one, the intermolecular force. The intermolecular force of attraction in liquid is weaker than solid. Take note of this. The intermolecular force of attraction in liquid is weaker than what? Than solid. That is why you can see liquid can what? Flow. Liquid can flow. It has a weaker intermolecular force of attraction between its molecule. Another one. Liquid has lower density than solid. It has lower density than solid. Another one, the space between the particles of liquid is considerable. That means you see as what? Little space. Is what? Little space. There is still little space between the molecules of what? Liquid. Take note of that. Take note of that. Let us go to what? Properties of what? Gas. Properties of gas. Let me rub off this one. Properties of gas. 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 Number one, gas has no fixed shape and no fixed volume. It has no fixed shape, no fixed volume. Another one, gas can be, this one can be compressed, highly compressible. Can be compressed. It is highly compressible. Next one, gas has the lowest density out of the three of them. Has the lowest what? Has the lowest density out of the three of them. Out of the intermolecular force of attraction. Intermolecular force of attraction. Intermolecular force of attraction of a gas. is the weakest. He has the weakest intermolecular force of attraction. The weakest intermolecular force of attraction. He has the weakest intermolecular force of attraction. The space between the particles of solid, of gas rather, of gases or of a gas is large. Take note. The space between the particles of a gas is what? Large. Take note of that. Then let us move to what? Physical properties and chemical properties. Let's look at physical and chemical changes. That is changes of matter. Don't forget, I told you that matter can be studied in form of a physical change and chemical change. Or matter can be described in terms of what? Physical change and chemical change. Let us look at physical change. Physical change. What's the meaning of physical change? Physical change and factors that affect physical change. We are going to look at the differences between physical change and chemical change. And those differences can also be known as what? Characteristic of what? Each one of them. Take note of that. Physical change. What is a physical change? This is a change that is easily reversible and no new substance is formed. This is a change that is reversible and there's no formation of a new substance. Take note, this is a change. This is a change that is easily reversible or that is reversible. Reversible and no new substance is formed. And no new substance is formed. That means during what? Physical change, there's no what? New substance. Before I move forward, please, I want you to subscribe to this what? YouTube channel, to our YouTube channel. The name of our YouTube channel is what? NeoTisa is the best what? Online learning platform. The best online learning platform rather, the best online learning platform in what? In Nigeria, West Africa, and Africa as a whole. Please subscribe to this what? NeoTisa School platform on YouTube. Please comment on it, like, and please help us to share this to your friends from SS1 to what? 100 level. Science, medical sciences, biological sciences, environmental sciences, and what? Engineering. Jamb, Waec, SS1 to what? SS3, Jupeb, and 100 level. We are here for you to give you the best on every science subject that you take. On every science subject you take. Please share this with your friend. Please subscribe. Don't forget to press to punch the subscribe button. Please, thank you. Please, let's continue. I said this is a change that is reversible and no new substance is formed. This change is very reversible. No new substance is formed. And what are the examples of what? Physical change. Example of physical change. We have examples of physical change. We have, take note of this. Interconversion of state of matter are all physical change. Take note of that. Interconversion that we did. The first thing we did in this video. Interconversion of state of matter are all physical change. That means melting of ice, freezing of what? Liquid or freezing of water, melting of ice, boiling. They are all what? Physical change. Boiling point, melting point, freezing point. They are what? Example of what? Physical change. Let us write it. Example of physical change. We have melting. of ice, freezing of water. Take note of this. When you dissolve salt in water, dissolution of salt in water or dissolving of salt in water is an example of what? Physical change. When you have salt plus water, is easily reversible. It gives salt solution. It gives what? Salt solution. It's an example of what? Physical change. Take note, we have melting of ice, freezing of water, salt solution. We have so many and so many. They are example of what? Physical change. It's a change that is easily reversible and no new substance is formed. Take note of that. Sublimation process is a physical change. Condensation process is what? Physical change. Physical change results in what? It can result in change of size or the shape of a matter. Physical change can result in what? In the change of what? The shape, rather. The shape can result. For example, when you have this paper, if I tear this paper, that means it's a physical change. It's a physical change. Take note of that. Physical change is a change that is what? Is easily reversible or that is reversible and no new substance is formed. Or interconversion of state of matter are what? Physical change. Let us move. Chemical change. Chemical change is an opposite of a physical change. Chemical change. This is a change. This is a change that is not reversible. That means it is irreversible. It is irreversible. That is not reversible. That means it is irreversible. And new substance is formed. A new substance is formed. And before I go further on this, I should have given you this. What are the factors that cause physical change? I should have given you this before I move to chemical change. What are those things that cause physical change? Factors that what cause physical change. Take notes. Factors that cause physical change. We have temperature. Can cause physical change. Pressure causes physical change. Take note. These factors cause what? Physical change. These factors what? Cause increase in any one of these two factors can what? Cause what? A change in the what? State of matter. And when they are reduced, that change can easily what? Be reversed. Increase in any one of these two factors can cause what? Change in state of matter. And when any one of them is reduced, when they are reduced, that what? Matter, change in state of matter can what? Easily be what? Reversed. Take note of that. These two factors cause what? Physical change. They can ask you which of the following factors can cause what? Physical change. You will see one of these two factors in the option. Take note of that. Then let's go back to this. Chemical change. I said this is a change that is not reversible. That means it is irreversible. A new substance is formed. Example. Let me give you example. E.g. Example. What do we have? Example. We have neutralization reaction. It's an example of what? Physical change, of chemical change. Rusting of iron. Take note. Rusting of iron is an example of physical change. When you have what? Rust iron, that means iron 3. You can't get back the new iron. Take note of that. When acid and base react to form salt and water, you can't get back the acid and base from salt and water. That is neutralization reaction. We have slaking of lime. What is the meaning of slaking of lime? When what? quicklime react with water. When quicklime, that is calcium oxide, react with what? Water. That is flaking of lime to form calcium hydroxide. To form calcium hydroxide. To form calcium hydroxide. That is flaking of lime. It's an example. When flaking of lime, when you have quicklime, that is calcium oxide and water. That is flaking of lime. It's an example of what? Chemical change. We have burning of wood. Burning of wood. Burning of wood. That means I can simply say combustion reaction is an example of what? Chemical change. Combustion reaction is an example of chemical change. Take note of that. ETC. ETC. We have ETC. Then let us move further. Let us look at the word differences. Differences between physical change and chemical change. Differences between physical change and chemical change. One love. Let's look at that. Differences, please, between physical change and what? Chemical change. Differences. Differences. Differences between physical change and chemical change. Differences between physical change and chemical change. Differences, let me give it to you in the form of a table. There you have physical change, yeah? Physical change. You have chemical change here. Chemical change. The first one, number one, physical change. It is reversible. Reversible. It is reversible. This one, irreversible. Chemical change is what? Irreversible. Chemical change is what? Irreversible. That means it is not reversible. Chemical change is what? Irreversible. It is irreversible. That means it is not reversible. Another difference. No new substance. No new substance is formed. No new substance is formed. Under this, new substance is formed. Under this, no change in mass of the substance involved. In this one, no change in mass of the substance that is involved in what? Physical change. For example, if you have your liquid in your water in liquid state, and you have a particular mass of that water, if you put it in your deep freezer and it changes to what? It changes to what? Ice block. The mass still remains the same. Take note of that. The mass will still remain the same. That means in this one, no change in mass of the substance involved. But here, there is change. There is change. There is change in mass of the substance involved. Another one. Under this. Under this. No it or little amount, or let me say, no it is involved. No it is involved, or little amount of it is involved. Let me explain. No it is involved or little amount of it is involved. For example, when you have ice changing toward liquid. In this case, this ice will absorb what? Heat from its environment. That is what? Latent heat of fusion. Latent heat. Just little amount of heat is what involved. That's why I say it's either there's no heat involved. Take note. Or little amount of heat is what? Involved. Take note. No heat involved or little amount of heat, like latent heat of fusion, latent heat of vaporization, when liquid change to what? Gas or vapor, latent heat of vaporization. Little amount of heat or no heat is what? Involved. But under this one, great amount of heat, is involved. Great amount of heat is involved. That means great amount of heat can be released or can be what? Absorbed during what? Chemical change. Great amount of heat is what? Involved. Great amount of heat is involved. Please take note of this one. Differences between what? Physical change and chemical change. Let us go to the last part that is there in your Jupeb. Is there in Jupeb, and they can ask you this question in Jamb. This question can be asked in Jamb. Take note, we have what we call intensive and extensive property. Take note of that. Physical change is associated with physical properties. Take note of that. Physical change is associated with what? Physical properties. Chemical change is associated with what? Chemical properties. And these two properties rather, physical properties, chemical properties, can be intensive and can be what? Extensive property. Then let us look at the meaning of intensive property and what? Extensive what? Property. And their what? Examples. Is there in what? Jupeb 2015 or 2016. They say define intensive and extensive property and give 3 examples of each. Let us look at that. Let us look at that. Let us look at that. Please, let us look at that. Let's look at that. Because I have few minutes left to end this class. Few minutes left to end this class. Few minutes left. Intensive properties, which can also be called intrinsic properties. We can also be called intrinsic properties. Intensive properties is also called intrinsic property. What is intensive property? This is a property that do not depend on the amount of what? Matter. These are properties that do not depend on the quantity. Quantity means amount, on the quantity or size of matter. They do not depend on quantity or size of matter. They do not depend on quantity or size of matter. Let me give you an example. Melting point. Melting point. We have boiling point. Freezing point. We have conductivity. We have ductility. We have odor. We have color, etc. They do not depend on what? On quantity or size of matter. Then let us look at the last one. Extensive properties. Another name for extensive property is what? Extrinsic property. It's an opposite of this. This one depends on what? On the quantity or size of matter. These are properties that depend on the quantity or the amount. The quantity that depends on the quantity that depend on the quantity or size of matter. That depend on the quantity or size of matter. Example, we have mass, we have weight, we have length. Yeah. We have length. Yeah. We have each content, etc. These are what extensive property. Take note of that. Please subscribe to our YouTube channel. Please subscribe. Press the subscribe button. Share, like, then comment. Then you will see a link under it to join our WhatsApp group where you can ask so many questions. And if you need one physical or online classes, you can call us. You will see the number on the WhatsApp link below this video. I remain myself, Jamb. One love.